Yes. We're going to start in 5 minutes as there is still people registering. Thank you. Okay, I think slowly we can start, please. It's about time. Okay, so I'm just waiting for a couple of persons, I think. Okay. Okay, so welcome everybody to Brussels, to the Impress Me final event. I am Vicky Mosterin. I'm the Managing Director of Greenovate Europe, based here in Brussels. Greenovate Europe, we are partners to Impress Me. We are a European net. Did somebody say? Is the echo? Sorry, I can't hear an echo. Greenovate Europe is a European network of organizations working for sustainable innovation. Excuse me, Patrick, please do it. We are based in Brussels. We gather around 30 members working on sustainable innovation. We have research centers, technical centers, agencies working on communication and dissemination, exploitation, stakeholder engagement, and so on. In Impress Me, we have 3 members. So we deal with communication and dissemination and stakeholder engagement. We have Rice, who's been responsible for one of the pilots, of which we will be hearing later on. We have Leonardo, responsible for all the training activities. We have Eski, responsible for, together with us, for some of the communication and dissemination activities. So here we are today, and the reason we are here is mainly to learn from new bio-based solutions to support the acceleration and on circular economy. Impress Me has developed new bio-based solutions for European companies on the sectors of packaging, energy, transport, and consumer goods. We're going to be listening to those in a moment, but not from me. It is one of the only ones remaining Horizon 2020 projects. It started in January 2021 and gathers 27 partners coming from 9 different countries, which, as probably most of you know, it is a big consortium, a big group. It has been led by BTT, which is the Technical Research Center of Finland, and very well done, very difficult and challenging and technical project. And in a minute, we're going to be listening from the coordinator from BTT. And just to say that we will be finishing around 10 to 6, I believe, and at 6, as we are a satellite event, whatever that means, of another conference, which is called Pitch Perfect and Boosting the European Bioeconomy. Please don't miss that. It's also here, starting at 6 o'clock. And there it will be the occasion to mingle, but also to listen to some of the European representatives from the European Commission and I guess other bodies and institutions. So it's the opportunity. And that's why we're sitting here today at the Sheraton Hotel. I hope I didn't forget anything. And with that, I will present Ilona. Just 1 second for this. I need my glasses. Sorry. So I make sure I pronounce well your name. Ilona Lepanen from BTT, so the Technical Research Center of Finland, and coordinators. Ilona is working as a senior scientist at BTT, developing novel bio-based and biodegradable materials from wood. Her work contributes to redefining the use of cellulose-based materials in the bioeconomy, presenting high-value applications for the forest sector. And Ilona, with this, the floor is yours. Thank you.
Thank you and welcome also on my behalf. And as Vicky mentioned, I'm Ilona from VTT, and I have been the project manager for the EU-funded project INN-PRESSME, and also the co-coordinator together with Ulla Forsström, who is unfortunately not able to be here today. But as our project is coming to an end in next January 2025, I would like to tell you about shortly the key results and achievements of our project and the lessons learned. So the main aim of the INN-PRESSME project has been to develop and implement a sustainable open innovation testbed to support the European companies to scale up their nano-enabled biomaterials and processes. And in the project, we have upgraded altogether 16 pilot lines across Europe in formulation, feedstock conversion, processing, and transformation from TRL levels 4 to 5 up to 6 to 7 to help support the companies and startups in Europe to scale up their materials. And what is also important in the INN-PRESSME has been that the materials are also recyclable and that we have used as little as possible fossil-based materials. And we have demonstrated the upscaling in 3 different sectors, which have included the consumer goods, energy and transportation, and packaging. And as Vicky already mentioned, we are a big consortium all around Europe, and the 27 partners are listed here. And these 17 partners are actually the partners who have provided the piloting facilities and also other services, such as biodegradability analysis, LCA analysis, market analysis, and recyclability studies. And then these on the bottom are actually industrial partners who we have worked together to upscale the demonstrators and hoping to move them towards industrial scale. So we have worked very closely also with the industrial partners. And then more closely to the results and achievements. So first I will tell you a little bit more about the pilot lines that we have upgraded. And then these pilot lines were validated with 9 different test cases in the 3 sectors that I mentioned to you previously. Then we have organized also 2 open calls during the project where we have got then 11 additional test cases. And here companies around Europe could apply to scale up their bio-based innovations, and we have helped them with that. And what is of course important in the EU project is the dissemination and communication. And then I will give a quick view about the future of INN-PRESSME as we are planning to continue the work also after the EU project is ending. So altogether, we have upgraded 16 pilot lines in feedstock conversion, formulation, transformation, and processing, almost all of the pilot lines reaching TRL level 6 to 7. And in the feedstock conversion, we have 4 pilot lines in the production of different nanocellulose grades. Then we have production of hemp and flax microfibers and also polyhydroxyalkanoates. In the formulation, we have also 4 pilot lines, and these include formulation for bio-based inks and slurries, graphene and carbon nanomaterials, inorganic and organic hybrid materials, and polylactic acid-based water dispersions. And then finally, the transformation and processing, we have 8 pilot lines that we have upgraded. Those have included 3D printing, electrode manufacturing, surface treatment and coating, multi-nanolayering of films, extrusion, injection molding, and bead forming. So quite many pilot lines and possibilities to upscale many different materials using different processes. And these upgrades have enabled more efficient data collection, and now it's possible to store all the data from the upscaling trials, and this makes, of course, also the process monitoring much more efficient. In addition, we have improved our quality control tools to increase the quality of the production. And then finally, we have also included new reactors and production lines and installed those to increase also the production capacity and yield of the pilot lines. Then these 16 pilot lines were validated with the different test cases. And for the test cases, we have the 3 sectors: packaging, energy and transport, and consumer goods. And there on the right, you can see all the different 9 test cases that we have upscaled during the project. And in the packaging, we have, I don't know if this, there. We have the bio-based smart label here. Then we have the fiber-based packaging pouch. Then the bio-based box, which is replacing expanded polystyrene boxes. And then also bio-based tubes for cosmetics. In the energy and transport, we have 2 different automotive parts, both for the interior and exterior of the car, and then also electrodes for ultracapacitors. And there's also an image there. Then for the consumer goods, we have personalized shoe soles and then also sports goods. And actually, these 4 test cases are presenting here today, so you will hear a little bit more specifics about those test cases later today. Then during the last 2 years of the project, we have organized the open calls, as I mentioned to you, in which actually SME startups and other companies have been able to apply to upscale their innovative bio-based solutions. And these have been done with the EU funding, so there has been altogether 1.6 million euros funding to help the SMEs and startups. And altogether, there was 11 open call test cases that were successfully carried out, and they came from 9 different countries all around Europe. And we see there that the different pilot lines were very nicely used in all of these new test cases. And the open calls were basically done in this EU project to validate that this kind of OITB system works, and also that our pilot lines can serve the real customers also all around Europe. Here are all the companies that were funded by the INN-PRESSME to scale up their solutions. And we see on the right-hand column that we are representing quite many different markets, which is very nice. And actually, these ones here are today presenting their own bio-based innovations, and they work together with the INN-PRESSME OITB later today. Then, of course, what is important in your project is the dissemination and communication, and here are some facts and figures of our project. And maybe a few highlights would be the videos that we have published on our website and YouTube. So you can, with the QR code, you're able to access all the videos about the pilot lines if you want to know more about the pilot lines. And also there is altogether 16 public deliverables that will be published from the project, and 12 of them are already available in the INN-PRESSME website. And those are related, for example, to nanosafety, eco-design, and then there is also a deliverable, for example, about the procedures of the open call and the selection criteria for the open calls. So then, what is the future of INN-PRESSME? So we are not, the story is not ending for this project. So the main outcome of the INN-PRESSME project will be a sustainable and operational open innovation testbed that can serve the potential customers around Europe. And they will have access to all of these pilot lines to one contact point, which is the single entry point, and that will be managed by one of the partners, which is TAM, then after the project is ending. So this will help the companies then to help them to access these advanced facilities. They will help to accelerate the innovation and development of their bio-based solutions. And then, of course, they will save time and cost by using the ready-to-use facilities, so they don't need to start building them by their own, so they can have a proof of concept by using our pilot lines. So then finally, quickly, how does it then work? So the clients have a question, they would want to scale up or test their own materials and to use our pilot lines. So they contact the single entry point, and through that single entry point, they have access to all the different pilot lines and also the other services such as biodegradability analysis and LCA through through the OITB. And after that, they will then have end products made from their materials or goods, and also more information about the feasibility of their scale-up process and how they need to fine-tune the procedures to scale them up further. And for more contact information from the OITB, there is the contact from STAM who you can reach. And with that, I would like to thank you and then give stage to the open call winners and also the test case presentations.
Thank you so much, Ilona. I believe we have time for questions in 2 sessions, no? So hold your questions to Ilona, because there will be a little time for questions and answers in a minute, but I mean in some minutes. Before that, we go to the next session, which is on recycling policies and packaging regulations. And we will have Antro Saila, I hope I'm pronouncing good, from Packhouse Finnish Packaging Association. So Antro has a lot of hats, I see. So he's the CEO of Packhouse, the Finnish Packaging Association, but he's also the head of public relations of Packhouse and closely follows the development of packaging-related regulation in the European Union and in Finland. Antro also holds several positions of trust. He's president of EPIC, the European Packaging Institutes Consortium, chairman of RINKI, the Packaging Recycling Ltd, chairman of National Packaging Standardization Committee, member of board of the Scandinavian Packaging Association, and member of board of World Packaging Organization. I hope you get some sleep with all these responsibilities. So please, the floor is yours.
Yeah, thank you. Thank you very much. I think the pronunciation at least was perfect. Okay. Okay. Yep. Here we go. So I'll be walking you through some of the packaging-related regulations or regulatory items during the next 10 minutes. So I put the EU recycling policies and packaging regulations and opportunities or threats. So let's have a look on some of the milestones concerning the packaging regulation in European Union and also globally. One could say that from the beginning of the history of packaging, most earliest packagings must have been the wine amphoras that have been discovered by archaeologists. And even at that time, there were some rules and regulations related to health and safety of the consumers. And this was actually the most important thing within the packaging-related regulations until, I would say, in the 1980s. In 1980s, I think our Swedish neighbors, from Finnish point of view, invented a concept of producer responsibility, which is a good concept, and I think that it will be growing wider in the world in the coming years as we are paying more attention to environmental matters. Then 1996, EU Packaging and Packaging Waste Directive was introduced. In 2000, since 2000, we have seen and witnessed the rise of awareness on environmental issues, not only in packaging, but in general. 2008, EU introduced the Waste Framework Directive. 2016, we saw the Circular Economy Package, which was then, let's say, part of the Circular Economy Package was EU Plastic Strategy, which was then again implemented by the SUP Directive, the Single-Use Plastics Directive, which came 2018, together with the revision of EU Packaging and Packaging Waste Directive. 2019 was the Single-Use Plastics Directive, and then we have seen something that some people call the tsunami of regulation on packaging. Corporate Sustainability Reporting Directive, Corporate Sustainability Due Diligence Directive, Eco-Design for Sustainable Products Regulation, and what we will see until before the end of this year is the PPWR, the Packaging and Packaging Waste Regulation. Let's have a closer look on what these things mean. So first of all, the waste hierarchy, which was introduced 2008. And the idea is that preventing waste is the preferred option, followed by preparing for reuse, recycling, recovery, and disposal or landfilling should be the last resort. Then something quite recent, actually, or something that we will see coming into live actually next year, because the Corporate Sustainability Reporting Directive, CSRD, will start to really become live 2025 concerning the fiscal year of 2024. And here also you can see that there is a big emphasis on environment. Several standards of reporting will be and have been created to look on the environmental matters, a very important thing. This is then followed by the Corporate Sustainability Due Diligence Directive, the CSDDD. And here also you can see that there is environmental impacts are mentioned, and they are a big part of this CSDDD. And this means that there is an obligation for companies to conduct appropriate human rights and environmental due diligence with respect to the operations of their subsidiaries and operations of their business partners in companies' change of activities. Then the next one is ESPR, the Eco-Design for Sustainable Products Regulation. And this will bring us a digital product passport. It brings us rules to address destruction of unsold consumer goods, and it will also provide tools for green public procurement in the future. And you know that public authorities in the EU spend a lot of money on purchasing works, goods and services. And this will help to steer these funds towards something which is more sustainable. These are not all related directly with packaging. For instance, this ESPR says that actually the PPWR, the Packaging and Packaging Waste Regulation, should be taking care of these issues for packaging. But there is a but. In the recitals of the regulation, it says that also in some cases, packaging could be targeted by ESPR. So it's not for sure and certain that packaging is totally out of the hook. And then maybe the most important and interesting part of the regulation, regulatory word and framework of EU when it comes to packaging is of course the Packaging and Packaging Waste Regulation, which originally was created as directive. So what was the original target for PPWD of those times? It was to improve the quality of the environment, to protect human health, protect resources, and ensure the functioning of the internal market and restrictions on competition within the EU. The PPWD was revised in 2018 with some new features, preventing the production of packaging waste and promoting the reuse, recycling, and other forms of recovering of packaging waste instead of its final disposal, so to respect the waste hierarchy of the EU, thus contributing to the transition towards a circular economy. And then what the EU Commission proposed roughly 2 years ago, it was at the end of November 2022, when they came out with this kind of structure, where the Commission identified 3 areas of problems: high and growing number of packaging waste, barriers to packaging circularity, and finally low level of uptake of recycled content, with respective areas of intervention and a huge number of different measures to tackle these challenges. I have put a red square around some of these issues. I'm not going to run them through and explain to you them in detail, because you know them all already, most of you, and they are not maybe interesting all. But I mentioned a couple of things here. First of all, the growing number of packaging waste. I think, well, the idea of reducing packaging waste is a good one. But then again, if we at the same time say that all packaging must be reusable or recyclable by 2030, then the question is that is there a problem with packaging waste if everything is reusable or recyclable? And here the targets sound quite, I would say, not so dramatic with 5% target until 2030. But as the start year of reference year for this reduction of packaging waste is 2018, actually we are talking about a reduction of 20%. And the question of most people is that realistic? I leave that to all of you. And then the increase of reuse of packaging. Well, reusable packaging is something that exists already for the business-to-business packaging world. But for the consumer packaging, reusable packaging is probably almost 100% out of the picture. For instance, in Finland, we used to have a deposit return scheme where we had reusable glass and plastic bottles. But we scrapped the system because we considered that it might be, breaking against the rules of the single market. Because then you have to have one and the same kind of bottle, or at least the number of bottles that you can include in a DSR cannot be totally limitless. Then the definition of recyclable packaging and design for recycling criteria. This is, of course, something which is really important. And here the question is that how is this going to be done? And as it was mentioned, I'm also involved in the standardization. And the standardization body of Europe, the CEN, is working together with the Commission, but it's not clear for everybody that who is going to actually draw these standards. And then finally, the recycled content targets for plastic packaging, which I think that the Commission should have started this whole operation with already 20 or 30 years ago, because the market has been looking for this. If it would have been obligatory and there would have been chances and clear rules and regulations about the recycled material usage, then I think the private money would have rushed into investing in new opportunities. So is the EU regulatory framework on packaging opportunity or a challenge? I'd say it's of course both. The opportunities, some of them are here. The waste hierarchy makes circularity the preferred option in waste management. Reporting standards make it easier to compare companies and products' environmental impact. Eco-design pushes for better environmental performance, which means smaller environmental impacts. Only recyclable or reusable packaging is allowed on EU market in the future, and this would also provide the public authorities clear set of tools for green public procurement. And as I mentioned, the mandatory recycled content in plastic packaging will boost investments and innovation. But there are of course challenges. Reuse will probably increase use of plastics, transportation of empty packaging, use of fresh water and detergents. So personally, I don't think that reuse of packaging or reusable packaging is a silver bullet. It's part of the solution, that's for sure. Administrative burden for companies will increase. New innovative products and solutions need to comply with EU-wise, there should be an S instead of R, requirements extremely quickly. So within 5 years, we have to comply with the recyclability rules, and that might be too quickly for new products. So if they should be recycled at scale, covering 80% of the European population in 5 years, I don't know, sounds quite a lot for me. And finally, lack of scientific data and impact assessment, which is general problem regarding packaging. Because all these rules and regulations, they have been put out there without really knowing what kind of volumes and what kind of end uses we are talking about when we are talking about packaging. Because the public national statistics authorities have never actually gathered packaging data until now. These new things like SUP directives and EPRs being more widely spread. So I would say that packaging is walking on a circular economy wire in European Union. Means that if your packaging is compatible with circular economy, and that means that it is based on renewable raw material, recyclable, biodegradable, reusable, recycled content, it has recycled content if it's plastic packaging, and it complies to food contact material regulation, which is to be revised. You stay on wire and have more business opportunities. But if you don't, then you risk of falling from wire and have less or no business opportunities in the future. With this slide, I want to finish my presentation. I think the circular economy in general is hard work. This is from a metal packaging collection bin from close to where I live. And you can see that there is a 15mm steel bar to prevent people from putting large metal objects like car engines in the box. But somebody has taken the pain to twist this 15mm steel bar and not to put something in, but to take something out. Maybe a small-sized person like a child that could throw out, valuable metals that can be sold to scrap dealers. With this image, I want to thank you very much for the opportunity to talk to you. And if you have any further questions now and maybe later, you have a chance.
Thank you so much. So interesting. I'm sure we have some questions on where are the solutions. But we have to wait one more presentation to be able to make those questions. So next one is Angela Martin from INN-PRESSME. So Angela is the legal advisor at Amplias, the Technological Institute of Plastics, which focuses on innovation and research in the plastic sector. Angela specializes in guiding companies on EU sustainability regulations and compliance with evolving legislation. So she's going to be talking to us on policy recommendations. Where is Angela? Sorry, she's online.
Hi. Okay, do you hear me?
Yes. Yes. 1 second, we're putting your presentation. We can change the slides for you. I don't know if she hears you. Angela, you can start.
I can start.
Yes, please. Thank you.
So, as you say, I'm from INN-PRESSME. So here is a briefly introduction to what is INN-PRESSME and what we do here. So, INN-PRESSME is a technology center that has more than 30 years of experience in the plastic sector. So what is our purpose? We have a double purpose. If you can change this slide, please. Is to add value to companies, to generate wealth and create employment, and also to add value to society to improve quality of life and ensure environmental sustainability. So to do this, we have more than 12,000 square meters of cutting-edge facilities, consisting basically of pilot plants and laboratories. So my topic today to the presentation is policy recommendations related to packaging regulations and to biomaterials. Okay. So the index of the presentation. First, I'm going to do a little bit of introduction to what a biomaterial is, and I'm going to focus on the bioplastics. And then I'm going to explain what is the current European Union regulatory framework for biomaterials in packaging. And finally, I will explain some policy recommendations and the conclusions. Okay, so the introduction. First, I'm going to explain what is a biomaterial and more concretely, what is a bioplastic. So often there are problems with terminology and how to determine what is considered a bioplastic. To identify biomaterials, in particular the bioplastics, we can see this figure with consists on two axes. One is related to the origin of the carbon, whether it is from fossil or renewable sources. That is what we call a biobase, if it's from renewable sources. The other axis is related to the end of life of the product. And according to that, we can divide from biodegradable products or non-biodegradable. To start explaining the figure or the graphic, let's look at the case of what will never be a bioplastic, which are what we know as conventional plastics. So these are plastics that come from fossil sources and which do not biodegrade. It's basically nearly all conventional plastics as, for example, PE, PP, or PET. Okay, so in the next slide, we can see the first definition of a bioplastic. Okay, so first we have bioplastics that come from renewable sources, for example, from agriculture, but do not biodegrade. These plastics, in practice, are very similar to conventional plastics since they do not biodegrade and follow the same recycling flow as a conventional plastic. So it is a bioplastic because it's bio-based, but it's very similar to conventional plastics because it don't have the capability of biodegradation. So now in the follow slide, we are going to see the other kind of bioplastics. These bioplastics are bioplastics which they are biodegradable. So here is where the biodegradation is produced. And how is the biodegradation process? So this biodegradation is produced by the action of microorganisms such as bacteria and fungi that are present in different environments and produce the transformation of plastic into carbon, water, mineral salts, and biomass. So depending whether they come from renewable sources or non-renewable sources, we have different kind of plastics such as PLA or PHA, which become from renewable sources, so are bio-based bioplastics and biodegradable. And we have other kind of bioplastics that are also biodegradable, but which come from fossil-based sources such as oil. So here we have PBAs or PCL as an example. Okay, so I'm going to move on to the next slide. And here we want to put the focus on which are the biodegradability issues. So one of the main problems with biodegradability is that it is often misunderstood by the consumers. Firstly, and continuing with the problems of terminology, biodegradability by itself does not mean anything. So we have to explain biodegradability putting a surname. For example, if we have a bioplastic that is soil biodegradable, we have to indicate that if this plastic or bioplastic biodegrades in soil, indicating always the condition in which this biodegradation happens. Or another example is if the product biodegrades in compost, which is the most common medium. So we have to indicate this biodegrades in compost. This is like the surname to indicate in which environment this biodegradability happens. And the other mainly issue is that although a product biodegrades in composting conditions, this should not be confused with the fact that the product can be abandoned in the environment. Since by doing so, we only be polluting and harming the environment. For composting to occur correctly, the product must undergo a transformation and valorization process to ensure that it is adequately recovered. So, as a to summarize what I have explained, the important thing is that biodegradability by itself does not add value and can be misunderstood by the customer, and this leads to relax their commitment or obligation to the waste. So the priority must be to avoid littering and to recover waste through coordinated and realistic communication in order to make the best use of resources and avoid pollution. Okay, now following the presentation, we have this slide that is explaining the different bioplastics families versus the biodegradability environment. So basically here is a demonstration that not all bioplastics biodegrade in the same conditions, and therefore it is important to always indicate in which environment this biodegradation occurs, and it is also important to take into account the biodegradation environment according to the application of the product. For example, it might be interesting for a fertilizer to biodegrade in soil because it is very difficult to recover the remains of that fertilizer, and if it biodegrades in soil, it does not contaminate in the same way as if it did not biodegrade. So this is an example. And now I'm going to move on to the next topic, that is the current European Union regulatory framework. So in this slide, we have like several policies, many of them related to the European Green Pact, have the potential to boost the role of bioplastics in the development of a truly circular bioeconomy, enable innovation and attracting new investments. In order to contribute to this European Union ambitious climate goals, it is important that is followed but with relevant legislation to acknowledge the important role of bioplastics within a circular economy. In recent years, the European Union has made increasingly efforts to introduce or adapt policies, regulatory framework, and standards to strengthen and implement the bioeconomy and the circular economy in Europe, all of which affect the bioplastic sector in one way or another. So some of the examples of the legislation in this area that the European Union has approved are the directive on the reduction of the impact of certain plastics products on the environment, and it is also very important the proposal for a regulation on packaging and packaging waste that will be published soon. And we have also other relevant documents such as the European Green Deal. Okay, so now to conclude the presentation, I'm going to explain some policy recommendations and the conclusions. So the plastic sector maintains its competitiveness by consciously improving the environmental impacts for its products. The communication of these environmental improvements is key to promote this the use of these environmentally friendly plastic products. So to do this communication and to show truthful information, we have the eco-labeling as a tool. Eco-labeling of products according to recognized schemes and based on international standards is the most recommended options for these effective and also reliable communications. As I explained at the beginning, bioplastics can be bio-based or attending to end of life can be compostable or biodegradable. However, simply because a product is made of such bioplastics does not guarantee that it meets this condition. So in order to demonstrate this, there are the environmental labels focused on these parts of its life cycles, on the origin of the carbon or on the end of life of the product, indicating if this product is biodegradable or it's not biodegradable, for which the testing requirements and characteristics described in the regulations and application schemes must be met. So as an example, we have here this graphic showing some of the eco-labels at the European Union. It's important the TÜV and DIN certification, and we have different eco-labels depending on the environmental on the environment or of which this biodegradation happens. For example, like industrial composting, home composting, soil, or marine, and the conditions in which this biodegradation happens. So this is all the presentations. If you have any doubts later, I can answer them. Thank you.
Thank you very much, Angela. Thank you. Okay, so now we have 10 minutes for questions and answers for the three speakers, previous speakers. So don't be shy. Any questions? We have micros. No questions? Yes, thank you. Please introduce yourself quickly. Thank you.
Hello, my name is Daniel Falk. I'm from Colorado in the United States, working on a biofuel startup from municipal wastewater. I was curious for Antro, for the producer. I've also worked in biomaterials and conversion processes in Colorado as well. What is your view of the producer responsibility for the financial part of converting the waste into usable or recyclable materials?
I think that the producer responsibility, the EPR, as we call it, extended producer responsibility, is a great concept, and I think that's a very, very important, and in the future even more important part of the EPR. I think that it is something that we have to pay much more attention to.
Thank you for the presentations. My name is Wim Hartjes from DG Research and Innovation. I have a question for the first speaker who said that, who talked about the results and the achievements and the lessons learned, indicating also that the Open Innovation Test Bed will continue to operate. But how would that work in terms of business model? What would it, how do you finance the continuation of the test bed? What is it, is there a change in cost towards the companies, or so a bit more information about that?
Yes, so we are still fine-tuning all the agreements and so on, as the project is not ended. But basically then STAM will be the partner who is providing or which is the contact point for the customers, and we are providing then the services, and there will be some financing like for the start, and then after that there will be a provision added to the project, which will then help STAM continue the work. So it will come through the projects.
Thank you. More questions? Yes, please. Thank you.
Good afternoon, Sandrine Lebig from IPC, the French Technical Center for Plastics and Composites. I've got one question for you, Antro, about the PPWR and its impact on the development of bio-based products. Do you think that PPWR will boost the bio-based economy or the contrary?
A good question. That's I would say that the bio-based industry, for instance, forest industry. I'm a forester by education myself. I've been working for the Finnish forest industry companies, and I think that the forest industry has hoped and believed that most of these things that pay more attention on environmental matters would boost bio-based industry, because bio-based industry using renewable raw material, etc., hopes that they are being considered as something environmentally better than something else. For instance, plastics industry, which is still based on fossil raw materials. But so far, it has not been the case. It's been the opposite, because actually usage of even renewable raw materials is not considered automatically better than something else. So I think that we are really wondering in this world that what is environmentally better than something else. And that's why I think that that's why I was talking about these, for instance, these corporate sustainability reporting directives and other things, that I think this is something that we would have needed to have before setting any targets or building any business opportunities on different industries. First, to understand what are the environmental impacts, and then instead of politically setting the bar at a certain level, I think the reduction of environmental impact, no matter what the environmental impact is and where it is coming from, should have been the thing, instead of just getting these funny ideas that let's use more reusable packaging.
Thank you. Any more questions? I might have one also for you. Yes. No, I was a little bit shocked that you said that the Commission was running 20 years behind because the market was asking for some solutions that could have been taken already 20 years ago. I'm sorry, now that the Commission is at the room, maybe it's a good moment. Yeah, a representative of the Commission, to be a little bit provocative. Is it still the case? Is the Commission today 20 years behind, or the time period has been shortened, or what do you think?
Well, obviously, I was trying to be provocative also. It's just to be noticed, because speaking about these things smoothly and patting on people's and organizations' heads usually is not leading to anything. I think that the big problem is that we all want to live more sustainably. We as consumers, me as a parent and a grandparent, my company or the member companies of my association, or the administration or the Commission, we all would like to be more sustainable, but we don't have tools for that. So that's why I was saying that first we should understand, and this thing about packaging and the statistics is something that would open the eyes for many people. We have seen now this tsunami on packaging regulation, and the intentions are good. Intentions are good. Intentions are good, but unfortunately, they are not hitting the target. Because there's lack of information. For instance, SUP directive, single-use plastics directive, it says that we have to reduce one portion size plastic packaging, single-use plastic packaging. And that was decided in 2019, and now we are living at close to end of 2024. We still don't know what the volume of this kind of packaging is in Europe, where it is coming from, and what it consists of. So this just shows that we don't have the information to set these targets and to be politically ambitious. I think this is totally, it's like we would still believe in Mandrake or some of these cartoon figures that made these funny gestures with their hands and they changed things into something totally different. This is like believing in David Copperfield. I'm a great believer in market economy. I think that the market would guide us to the right direction if we just gave people the tools. I think that the energy efficiency indicator of household appliances is one of the best things that European Commission has come up with. You know, we are all buying washing machines and fridges and freezers that consume smaller and smaller amount of energy because it's clear. We have the indicator. But if you buy a packaging or food, you don't have a faintest idea of if it's good or bad or better than worse of the next package on the shelf. So that's why I'm saying that the Commission is not hitting its target. I think that the Commission is trying to do good things. But unfortunately, it's like our politicians, these SUP directives and PPWRs, all of a sudden, and not by coincidence, they are all popping up just before the elections. Because the politicians, they want to portray themselves being, efficient and hardworking. And I think that this is not true.
Thank you so much. But consumers, we can know if it's reuse. So reuse, you say it was not the, I don't want to start the whole debate.
No, but I honestly and genuinely, I think that we would like to be better, almost all of us, as companies, as nations, as individuals. But we don't have tools. We don't really have the clarity of if we make a choice in the supermarket that what is environmentally better than something else. And it's the same thing with the companies. That's why I think that these corporate sustainability reporting things are great, because it forces companies to first of all study about the environmental impact and to report on the environmental impact. Maybe the next thing is that we have a label that says that this company's products are better than the other companies, and then we can all decide whether we want to buy these or these goods.
I'm sure, thank you so much. I'm sure we could continue the discussion. I have more questions, but I keep for the coffee break. I think you wanted to add something to his answer. I saw it in your...
Why not law changes to, like, we outlaw poisonous foods, poisonous plastics, poisonous materials, and you make a cut?
Well, yeah, why not? But then we would really have to have the scientific facts and the data and the impact assessments. But now what we are doing is we want to rush into something which might then be proven to be totally wrong. It's like the Green Party in Finland. They were strongly opposing nuclear power, and now they are strongly in favor of the nuclear power. So I don't know. I'm becoming a little bit cynical about these things. I'm too old already. Yes. I think that what we need is really, we need research and we need science. We need facts and figures, and then let's then do the right thing when we really know what is the right thing, taking into consideration that everybody who works in science and has studied something knows that the basic thing of science is that with the new research we get new results, and then it turns something to something totally new. But then we just have to face that fact.
Thank you so much. Thank you very much. Okay, so we'll go now to a little panel discussion and presentation of the INN-PRESSME. Of all the INN-PRESSME test cases. I'm going to call the 4 presenters one by one. So first I have Jane Constantin Albrecht from Fraunhofer ICT. With a background in chemical engineering, Jane conducts research in bio-based polymer foams at Fraunhofer ICT in Prinzell, Germany since 2021. please come here. Then I have Rajesh Kopulu from BTT, who is a senior scientist at BTT. He specializes in scaling up technologies related to biomaterial processing for various novel and high-value applications, with a focus on sustainable packaging and energy transition. And he also manages public and commercial projects, ensuring effective execution and timely delivery. Yes, please. Then I have Marina Aspiros from Podoactiva. Marina is a biotechnologist that leads Podoactiva's research and development department, applying her experience in international personalized medicine projects to drive innovation in podiatry and biomechanics since 2018. And then I have Patricia Godel from Skeleton. Patricia is the head of grant financing and risk at Skeleton Technologies. Before joining Skeleton in 2020, she was working for a large transnational utilities company, setting up a unit for sustainable innovation. So thank you very much for the four of you. We're going to have a 5 minutes presentation for each of them, of the test, and then we will have a little, some questions and also time for questions and answers. So I will have, again, the glasses. I will have Jan Constantin Albrecht from Fraunhofer starting the first presentation. Thanks.
Thank you very much. So I'm happy to present the test case of upscaling bio-based boxes. No? Maybe
Now this one is better, I think.
Okay. Yeah, I'm happy to present the test case of upscaling bio-based boxes from the INN-PRESSME project. You can see our object of transfer on the right. So these boxes are mainly used in shipping cooled fishes and vegetables, and they are single-use products made from expandable polystyrene, which is a material with a really high CO2 footprint, which is mostly linked to its nature of being a petro-based material. So we wanted to change that and take this example to showcase the potential of bio-based plastics and bio-based materials, and also examine the recycling rate of those bio-based plastics. That breaks down to a technical aim of replacing those EPS materials, and therefore we had to increase the temperature stability of the biomaterials and also its mechanical properties to be a relevant substitute for EPS. We wanted to go a step further and not just use the more environmentally friendly materials, but also add some added value to the product and thus use PLA to generate a function integration, which you can see on the right here. So this is our demonstrator part, and we added this little card holder, which can be used to add an NFC chip, which constantly controls the temperature inside the bio-based box to ensure that the goods are not getting too warm. Technically, we chose PLA because it's a large scale and quite cheap biomaterial that is largely available. And we produced all the parts of the lid from it. So first of all, the lightweight foam was developed, a bead foam that is a drop-in solution for EPS. Also, the 3D printed inlay was developed, and another step was to combine those two in a process to really weld them together. Coming first of all to the 3D printed part here, 5 partners of INN-PRESSME were part of this development. BTT and IFNIRTS, here on the top, examined different fibers as reinforcements for PLA, which were then sent to CEA that compounded them into biopolymer compounds and tested it to characterize them and choose the mechanically strongest material. This material was then sent to IPC, who extruded those 3D printing filaments from it, and this filament was then sent to ITIP to print the inlays for the foam box, which you can see on the right. Regarding the foam development, we took a step into recipe development to increase the crystallinity of PLA to enhance its mechanical properties. And then the bead foams were extruded, were pre-foamed in a steam-based process, and then molded into the final geometry, which is exactly the spot where EPS foams are used and produced with. You can see on the bottom right corner that we could, oh, that was too fast. One step back, yep. Okay, then I'll just tell you we could increase the compression strength of the foams by 60% by increasing the crystallinity to up to 25% in the material, and thus really compete with EPS foams. From our industrial partner WSVK, who did the foam molding, we have a nice video I'd like to show you, where you can see where the demonstrator was produced in industry scale machinery. So, and then we ended it with the final, final demonstrator you can see here or in your little leaflets on page 23, which is 100% based on renewable sources and is recyclable as it's just based on PLA. Thank you very much.
Rajesh from BTT.
Okay, so I will be talking about the test case about multi-layer. About the multi-layer fiber-based barrier packaging. So before that, I would like to just give a brief background about VTT in general. So VTT is like a publicly funded technical research organization of Finland. So we mostly do jointly funded projects within Finland and also with consortium partners outside Finland. And we also have public-private partnerships with some customers where we provide some research and development activities to the mostly European and North American customers, but we also have some customers from Asia. Where VTT operates is basically from the technology readiness level in between the universities and the industrial adaptation. So we still do quite a lot of fundamental research, but most of our focus is in the applied research. So we take whatever innovative technologies or concepts that were demonstrated in the laboratories, in the universities, and then we help the industry to scale them up, increase the TRL, so then the companies can then commercialize different concepts. So coming back to the topic, so we have been focusing on the multi-layer barrier packaging or based on papers. So typically when we take a barrier package that that is supposed to like give the prolong the shelf life of your products, it is a multi-layer structure. So it has several layers of plastic to provide different properties. So you have sealing layers, you have barrier layers, different types of barriers, oxygen, water vapor, grease, and so on. Some tie layers to bring them all together. You have some structural layers to provide the mechanical properties, and then some outer layers for extra moisture barrier and also to provide printing. So all of this makes recycling of a paper-based packaging very, very challenging because of the presence of the plastics, and also very difficult to biodegrade because of this. So the main aim is to produce a fully bio-based packaging that can be recycled in a paper stream. So we have worked with different materials, bio-based materials, so scaling them up from lab scale to raising the TRL to pilot scale. And then finally, we aim to coat these in a roll-to-roll process and make some stand-up pouches based on that. So these are the main functional materials that we use. So one is the polylactic acid-based water-based dispersion. So the PLA-X. X here stands that we do the polymerization reactions with the process that was developed in the project, and also with the pilot lines at VTT. So X means that it can be tailored. So we can change the crystallinity, we can change the glass transition temperature, molecular weight, and so on. So it's quite tailorable process to suit whatever the end product needs. And this is mainly used for providing water vapor and grease barriers. So we started with 2-liter scale, and then in the end of the project, we were able to produce at least 2 batches of 600 liters with quite good reproducibility. And then for the oxygen barrier, we used Bioeconomy, which is a biodegradable lacquer that was provided by Fraunhofer ISE. So it's a mix of inorganic particles like silanes and complexes and salts, and has some organic biopolymers, for example, hydroxypropyl cellulose as the binder. So this is basically to provide the oxygen barrier. So for first at the PLA-X, we coated at one of our partners, Valky's pilot line in Ylöjärvi in Finland. So it's an industrial scale pilot coater. So we were able to produce 5,000 meters of coated plaques on paper substrate. And then we got that substrate and then built on top of that and had multi-layer structure with the bioarmature layer and then a further plaques layer on top. So we totally had 3 different layers. And we produced about 2,000 meters of this 3-layer structure onto paper, and we had 2 different paper substrates. So about then in total 4,000 meters of paper was coated. So this is the structure that we have. So we have a base paper, then PLA-X, which is kind of like smoothing it and giving a little bit of moisture barrier. Then we have armature layer, which provides the oxygen barrier, and then a top PLA, which provides further moisture protection and also some heat sealability. And overall, they are like quite thin layers. So in total, we have less than 10 grams per square meter of all the 3 layers combined. So this is quite thin coatings. When we look at the water vapor barrier, we got about 65 to 70% reduction compared to the base paper itself, which already has quite good water vapor barrier. Oxygen barrier is about 2 cc per square meter per day. So this is for reference in close range to what we need for what high oxygen barrier products require. For example, coffee grounds packaging and those type of packaging. And we also have quite good barrier against mineral oils and grease. Here are some pictures on the pilot line at VTT where we made this multi-layer structure. So the coating head, and then we were reeling out the at the end, and then we finally made them into some demonstrator pouches out of that. We had some problems with heat sealability, so that still needs to be improved, but overall the concept works well, and we were able to get consistent quality in through different batches. Yes, thank you very much.
Yes. Okay. So, hello. Sorry. Good afternoon. I'm Marina Azpiroz, Research and Development Developer Manager from Podactiva, a Spanish company specialized in terms of podiatry and biomechanics. And I would like to show you our test case that is based on a 3D printed shoe sole made with sustainable materials. As you can see, this is our fashionable shoe. And this has been the work of some partners of the consortium. And the workflow of the test case it has been to provide the nanofibers, then the formulation and optimization of these materials. And then what we have done is to extrude the materials and then to be able to print it thanks to iTip. Also, Fraunhofer has developed a coating that is antibacterial and antifungal, and it is applied to the shoe sole. And then in Podactiva, as end user of the test case, we have made the inner sole assembly, the upper sole and the shoe sole itself, the design of the shoe sole, and then the validation with real patients. So the major achievements of the test case has been the final material itself, that is bio-TPU plus 5% of hemp. And then to print it, because it has been a real challenge, because it takes more or less 30 hours to print one side. And then the process, because as Podactiva, we made customized insoles, so we put it on the test case, our methodology, that is a 3D scan of the foot, as you can see with a 3D scan. Then the insole design with the indications of the podiatrist. And then we applied a technology in Podactiva that is a finite element technology to customize the insole. So what also has been a challenge is to mix the customized insole with the mesh of the sole, and then to obtain the final product, because it has a lot of work in terms of design to obtain the optimal. So then we make the validation of the product with instrumented insoles in 4 subjects in Podactiva headquarters, and a lifetime test of the shoe sole. And we see the difference between the mean, maximum peaks of pressures, and also the total contact surface. We are clinicals. So the different conditions that we test was the generic shoe without personalized insole, also the generic shoe with personalized Podactiva insole, and the last one, the INN-PRESSME custom footwear. So the key results obtained was that custom footwear of insole, of INN-PRESSME, sorry, could reduce the maximum peak pressures by up 20% more or less in comparison with generic shoes without personalized insole. So it's quite good result. And the utilization of custom footwear results in a 10% reduction of mean pressure on average, what is an indicator of the effectiveness of the biomechanical treatment. So what is the added value of the product? So the shoe sole, the customized shoe sole, has biomechanical benefits, also antimicrobial features and antifungal features thanks to the coatings added. It's sustainable because it has made with 100% of sustainable materials. And of course, the personalization through advanced design, because with 3D printing and with 3D scan, we can tailor the usual itself from a patient. So the potential future services for the industry will be personalization services, sustainable and eco-friendly solutions, also medical applications, because we can improve the biomechanics of the patients with that product, antimicrobial footwear solutions, and the last one, we think that we can make collaborative innovation models with brands to introduce in the industry this kind of materials into mass market products. So that's all. Thank you.
Hi, thanks everyone. I'm trying to be, oh, there it is. I only have 2 hands, so I'm gonna do something and actually pass. So Natalie was so kind to bring the prototype, so I'm gonna pass it around. So you can actually see it and touch it. Don't worry, it's not charged, so you can't hurt yourself. All right, so we have, I have a product that maybe requires slightly more explanation. It's ultracapacitors. Is there anyone here who maybe knows what an ultracapacitor is? All right, very good. Thank you so much. You get to be my favorite audience members. All right, ultracapacitor is an energy storage medium. Of course, it looks like a big battery. It's very similar to a battery. It does high power. So if you need a lot of power, like very, very quickly, and you need this power to come fast and go away fast again, then it's really, really great. Imagine, for example, you have a moment of a lot of sunshine, and you want to store that, and then you need to give it up back to the grid. So that's what a supercapacitor does really well. Or imagine someone comes up with AI, suddenly you have these huge, massive peaks in your grid because people want to use ChatGPT to do work that they maybe don't want to do themselves. That's also where an ultracapacitor is a really good idea. Ultracapacitors already have like a pretty decent environmental footprint compared to batteries. So there's no cobalt, no nickel, no graphite in there that is sort of harmful, but that doesn't stop us from making them better, because we think they can always be a little bit better. And I'm going to tell you a little bit about it. The slides are going to be a little bit technical, but I'm going to try to make it sort of hopefully understandable to everyone. And I also hope I pressed the right one. No, I didn't. There we go. All right. So there we go. So what we did in the project was, does this have? Oh, can I use this? Yeah. Okay. Okay. Great. So so this is what you see here. This is what we call the jelly roll. Essentially, it's the electrode that's rolled up really tight. What happens when you make an ultracapacitor? You have a bit of aluminium foil, you coat it with a material, and then you roll it up really tight, and you stuff it essentially in the little can that's being passed around. So the jelly roll is the rolled up stuff. Then the cell it becomes a cell when you put it in the little can, and then you have this thing where on top you have these little things that you need to charge and discharge, of course, the battery. Ultracapacitor. And we used the INN-PRESSME bio-based materials to make the electrode. So this bit, the coating of the electrode was done using more sustainable materials than we would ordinarily use, and we compared it to a regular. Oops, where it is? There it is. There it is. Compared it to a regular supercapacitor that we currently produce. And it comes to 79% of this industrial value. And you're going to say, oh, come on, we want the bio-based materials to be better. And our current product took us 10 years to develop to this point, right? And I think actually with like 4 years of INN-PRESSME work is actually incredibly impressive. I would not have thought maybe at the beginning of the project that we would get this far. And we will continue working on it, of course. So I have colleagues in Estonia who are actually currently working on this as we speak. So we get to 79%, I think. Like, give us another year or two, we'll get to 100, because this is actually a super nice result. So this is a sort of a little bit for the nerds among you. So we have here the current charge discharge cycles, and you see this. We tested a couple of times, and it comes out very consistent. So you don't have any kind of problems with this coming out one way one day and one way another. So we can keep this very stable, and it's obviously all produced to the same industrial standards. So we're not going to have to do a million changes when we do the industrial application for it, which is really important, of course, because these things are not. I mean, unlike the other stuff that we've seen, is not a customer regular customer product. I mean, you can buy these if you want one, but you probably can't do much with it. So we sell them to large industrial customers, so like automotive and so on. So they have really very strict standardized standards for us to adhere to. And here we have, so here we have sort of our final result. I've already shown you the capacitance, so almost there. The internal resistance here is still a little bit too high. We'd like to have this a little bit lower. So they are elevated here. You see a little bit, which is not ideal because it decreases the lifetime. And of course, we don't want to decrease the lifetime, because if you decrease the lifetime, you have to recycle it. And then you have all these quite valuable materials that are in there, like aluminium, and then you have to recycle them again. So at the moment, the industrial ultracapacitors can make it up to 15 years, and we would like to have the other one to have at least that, and maybe we can even increase to 20. But for that, we have to decrease the internal resistance still a little bit. But you see here in the last bit already, like what we think we will do, so we can actually manage this. So the electrode's density has to be changed a little bit through the coating weights. So this is now a question of how we actually produce it on the mass scale. So then we can have these sort of things sorted out. So we have to have our production equipment changed a little bit from what we usually do, and then hopefully we can get to like a very, very nice point. I think that's already it, because I thought I only have 5 minutes and I have a tendency to talk too much. So. Do you want this one?
Yes. Thank you so much. This is great. Thank you so much, Patricia. You did very well. And I'm going to go right to you because you were so fast. We are running out of time, but the idea now is that we have a little panel and then questions from you and then a coffee. So I'm going to make all of you a quick question, the same for the four of you. We'll start with Patricia. So what was for you the main challenges when developing your test case that you faced? A skeleton phase.
Honestly, I think at the beginning it was a little bit the internal concern that it wouldn't work. So we had to convince quite a lot of chemists who thought, bio-based materials, they're never going to be uniform, right? We need this sort of, all the products need to be super, super uniform so we can maintain the energy, and there's bio-based material never uniform. Can't we have something synthetic and so on? And we had to really talk internally to get people to.
And how did you convince them?
Well, I mean, partially by saying, hey, we have this project. You can, speak with a lot of smart people and get their help to get this done, which we didn't have in the original industrial product, right? We just had to do all the work ourselves. And then they were like, okay, right, maybe you catch me at my curiosity, and then we'll do it. And when it started working, then of course it was easy.
Well, indeed, curiosity is a great element for this kind of collaborative projects. Thank you, Patricia. Marina, same question.
Yes. For us, the most challenging part was to integrate the insole, because we are insole producers, to the same sole. Because for us it's new to develop the mesh, to be able to flex in the metatarsal area, and that kind of things related to design, and also to the 3D printing material, because it has to flex, as I said, in some areas. So it was the most difficult part for us. Yeah.
Thank you. Rajesh, please.
Yeah, I think it was quite same as what Patricia already said. It's like getting everybody on board, and especially we had people from different backgrounds. We had polymer chemists and then process guys. So it has been a little bit challenging to get everybody on board. So that was the difficult part, and then also the volumes were started to get bigger and bigger. We typically used to having maybe 10 liters and then maybe 10 meters of coating that we usually do. And now making hundreds of liters and thousands of meters of coating is like something that was like, are we a production line or are we a research organization, that kind of thing. But ultimately, we managed to solve those things.
Thank you. So you increased a lot the volume. You did increase that volume.
Yes, we eventually got there, yeah.
Thank you. Jana, please.
Yeah, for us, it was mainly the increased complexity of the material, which on the one hand takes up water, which is quite bad in a steam-based process, but we wanted to stick to the drop-in solution for industry. And on the other hand, the crystallization, which we could manage to improve properties actually, but brought some difficulties with it too. So we have a material that has 2 levels of complexity that EPS doesn't have. And then we had to bring this know-how to our industrial partners so that they could work with this new material in just a few days of trials together. That was difficult, but successful, I think.
Thank you very much. We'll do the questions in a minute, but before that, second question, also the same for all of you. What are the main benefits for you of integrating the biomaterials into your industry processes, into the industry processes? That's generalist.
So energy storage, I mean, you've probably all heard of the battery directive. So the European Commission is pushing this very hard. And of course, then the customers come back to us and say, hey guys, do you have this all traceable? Is this all sustainable? And then it's, you know, very nice for us to go and say, yeah, by the way, here's this, this, and this, and we've already run all the tests, and you can have this fully traceable. And then there's nothing that comes from, you know, critical places that maybe we don't want in our supply chain and all this stuff. And I think that is really nice. Yeah.
Perfect. Marina.
I think in our case it is clear because, you know, there is lots of footwear, but I think that the major part is made of rubber. So there is no footwear with sustainable materials in terms of the shoe sole. So I think it's the most different of all the
clear result. Thank you. Yes.
In our case, it's quite readily known, or kind of like from the beginning, is that we had to. We are in packaging field, and everybody wants to move into bio-based solutions and also show that these are actually possible to be done. I mean, we can have good properties and also can be produced at scale. So that was the initial get going, and I think in the end we were quite happy to actually be there and show that, okay, we can actually produce these materials and scale them up. Yep.
Perfect. Yes.
Yeah, one of the biggest advantages for us, or the biggest benefits, was that there are many countries discussing some regulations on EPS. For example, France is planning to ban it. Australia already did it partially. And so we could come up with a solution before those regulations are in place to really have a possibility to replace EPS before it is necessary.
Wonderful answers, all of you. So thank you very much. Questions for any of our 4 test representatives? No questions? Everybody prefers to discuss at coffee break. Yes, we have the commission. Do your research.
Okay, thank you for the presentation and very interesting developments. At what point do you start asking the question, is this going to be competitive? And have you done that within the project? Tried to look, I know it's too early, but at what point do you start having those discussions?
That's working now, yeah. Maybe I can go for the packaging case. So we right from the beginning, whenever we measure the properties that we get, we've always been benchmarking against the reference. What's the best one that we could get? And also when it comes to packaging, it's not one value that is the right one, because depending on the food and where it goes, it's there. So at this stage, I would say that as long as we are in tropical conditions is the most challenging one, and we are not there yet. But if we are in the European markets where typically the food goes into a controlled shelf or in the supermarkets and all, I think we are quite close to the real world applications. And I think few small things to be ironed out, but I would say we are going in the right direction, and we should be commercially ready quite soon.
I also meant in terms of price. How you compare to?
Yes, that's a challenging aspect. At this stage, the price is still on the higher side, mostly because of the volumes compared to the reference materials, and in general, biomaterials are a little bit more expensive. I would say that the price would always be a problem, but it will come down, but not to the stage that it is going to be cheaper than the reference ones. At least that's the stage that we are at the moment. The more people adapt, the more production volumes they are, it might come down in the future.
I mean, for us, it's still, the bio-based one is still more expensive when we look at price. This can be gotten down quite a bit through stronger mass production, more automatization, because at the moment, of course, these are prototypes only. We are also thinking about it from the point of view of de-risking the product, because if you have a supply chain that is bio-based, you have much better chances to get everything from Europe, which is something we really want, which in the long term, we believe will be cheaper than shipping from all over the world.
In our case, we think that we need time to introduce it into the market, because, as I said in my speech, we have problems with the printing of these materials, because, you know, one shoe sole, it takes 30 hours, so it's not prepared by the market today. But I think that in a long term, and with the developing of the 3D printers, it will be a nice product.
Yeah, for our test case, it's, I think, less the problem of technology, but more of raw material prices. So polystyrene is 3 times as cheap as PLA. And as we are using the same processes to foam it, we will stick to the higher price for the product. And I think, I don't want to be too pessimistic, but I think that for this packaging application, only a regulation will lead to industry paying that much more of a price.
Thank you. Pessimistic, or it's better to say realistic? More questions? If not, I invite you for the coffee break, where you can continue the questions, mingle, and get more information on our experts. And I don't know what time is it, but we have to be back at 4:30. I hope it's not 4:30. It is already? I know. So let's try to be back at 4:30, because we have another session till 10 to 6. Thank you. want to know some of the winners of the open calls. We have 6 of the 11 selected projects through the open calls that were presented earlier. I had the commission, the representative from the commission telling me he's doing a presentation in the other project, Biochip, but he'll be after presenting at the Pitch Perfect section. So he had to excuse himself, but he'll be back. And we're gonna look at these 6 successful projects that have been using the INN-PRESSME technologies and services. So the introduction is gonna be done by Yagoba Iturri from CIDETEC. Let me introduce you Yagoba, who is a senior researcher at the Smart and Functional Surfaces Unit within CIDETEC's Surface Engineering Division, where Yagoba works in mainly related to bio-based coatings and inks, active surfaces and paints. But he also acts as manager for several national and European projects and has taken active part within INN-PRESSME's open call as member of the organization board and as a technical participant. And are you going to present the...
Yeah, I have just very few slides. I wanted to make a very short introduction.
Perfect.
Before we go into the winning cases.
Okay, let me know if you... I have the bios.
Yeah.
Okay, perfect. Thank you. Go ahead, Yagoba.
Okay. Then, well, thanks for the introduction. Before we go into detail of the winning cases, I wanted to give some numbers about what the open call has been. I mean, CIDETEC, together with the STAM and BTT, has been coordinating the open call. This open call has been core part of INN-PRESSME project and core part of Work Package 7 of this project. And within this open call, what we wanted to do is this open call is split in 2 different cutoffs. We aimed at subsidizing at least 7-8 innovation concepts that could access our INN-PRESSME pilot lines, facilities and services, and in a way that the cost would be covered in kind in a ratio that was 70% covered by the consortium members as provided services and up to a maximum of 100 kilo euros, and the remaining 30% covered by the beneficiary industrial participant. The selection of these innovation concepts was done based on a selection of a group of evaluators, international one, that were giving their feedback based on the innovativeness of the proposals received, the concepts that were received, that were fitting the OITB assets, so things that could be done by us. And they also consider the TRL, this is starting around 4 to 5, and that over this implementation they could reach at least 1-2 levels more in TRL. The timeline of these 2, let's say, open calls was as it's depicted here. So we had a first part for the collection of the innovation concepts since the call was open. At the end of the collection, there was time for evaluation of the proposals and decision-making process. Then we had the selection of the winning proposals, and then there was a period for negotiation between industrial partners and our pilot line owners to check which kind of work could be developed. We had like first cutoff running from 1st of December 2022, already 2 years ago. And at the end of the process, the winning projects started by September of 2023. And the second cutoff starting 2nd of May 2023, and then the winning projects started their implementations by January this year. in comparison with the test cases we saw so far, these new projects got 9 months for the implementation compared to the few months more that the previous one got. So things got tight, but it was challenging, but a good challenge, I would say. Some summarizing numbers. So just to compare between both cutoffs. So during the first open call, we got 8 proposals, from which 7 were eligible, while during the second one, we got 16, from which all of them were eligible. And we got proposals from 10 different countries. At the end, we got an acceptance rejection ratio of 6:1 for the first open call, and then 7+2 because we had like 2 in the, let's say, waiting list, and then 7 of them got rejected. So we got very diverse topics. And regarding the selection process that I said, we had to build an international jury of experts. The first call had like 12 reviewers, while the second one had to rise up to 20 because of the larger number of proposals received. And this, in total, we had 8 different nationalities for the evaluators. Then this is a slide that was shown before by Ilona. At the end of the process and counting both cutoffs, we got 11 new test cases, 5 belonging to the first cutoff, 6 to the second one. So in total, this would reflect a 50% of acceptance in comparison with the total number of proposals received, representing 9 countries. And today, what we will see now in this block will be, let's say, a demonstration in a nutshell of what has been done. And we have participants from 6 of these 11 new test cases that will provide us with an overview of their work. So I guess this is the agenda, right? And this is all what I wanted to say. Yeah.
Thank you so much, Jagoba. And then we will start with Austria, with NAMBAT.
Yeah.
And I will call Christian Mehr to the floor. Christian is working as a research and development project manager at Wattens Papier, Delfort, responsible for development of innovative specialty paper grades for energy storage applications, and his focus is on new battery technologies, fiber-based separator solutions, and you are also involved in European projects. Thank you very much.
Thank you. Yeah, thank you for the intro and also the invitation to present the NAMBAT project. Yeah, about a year ago, we were approached by CEDETEC with the idea to participate in the NAMBAT project, and this acronym stands for Nano-Scale Cellulose Material, Enabling Sustainable Batteries for Mobility Application. And yeah, as usual, these titles convey the whole topic of the project. So if I want, yeah, okay, that was fast. Go into more detail, the NAMBAT project is shaped by cellulose, batteries, and sustainability. And the connection of those 3 topics is fiber-based separators. So it's a little bit shifted here, but the fiber-based separators consist of cellulose, which is an abundant raw material, basically used in all paper production processes, and it has unique properties when it comes to the design of this particular product. The fiber-based separators are used in some batteries and provide a unique cell design, which makes the batteries safer, makes them charge faster and last longer. And it's also synergizing with electrode-based formulations. And last but not least, sustainability is also a topic when it comes to fiber-based separators, since the upcoming regulations on battery design, which we heard before already, also will have an impact on the particular cell designs and battery designs, especially on maybe carbon footprint or recyclability. Okay. Since we now heard how ultracapacitors work, I will just briefly go into the details how a lithium-ion battery will work. And it's basically consisting of two active components, which is the anode and the cathode. And they are connected via an outer circuit. And they hold all the energy and consists typically of graphite, or in this case, LCO, as the cathode material. And if you fill the battery with a liquid electrolyte, it's basically able to do the charge transfer between the electrodes. But there's one thing that is still missing to inhibit something like short circuiting, because if the electrodes get in contact with each other, there will be a short circuit and a pretty violent, rapid discharge of the battery or explosion. So you use something like a separator to keep them distant and still enable the charge transfer between the both electrodes. So the separator should be at one as thin as possible to increase the energy density. Then it should be as porous as possible to allow the fast ion transfer. And third, it should be as insulating as possible to prevent the shorting. So this challenge is handled by Delford, where we produce the fiber-based separators on full-scale production machines. Cedar takes part of the cell production, the electrode manufacturing, and also the assembling of the pouch cells with the different separator types and their testing. And Incotec concluded this project with a market study to look into the different aspects of the innovation from fiber-based separators and its cost efficiency and its regulatory impact. So to summarize the collaboration with the different INN-PRESSME pilot lines and services, I want to emphasize the collaboration with CEDATEC and the production of the high-quality electrode materials that were really helpful in evaluating the cells afterwards, because it's really difficult if you just have one particular part in your battery cell that is different between all those types, which is the separator. So it's really important to have a high quality cell design. In total, 18 cells were produced, 2 ampere hours, so 6 cells each separator. The different types you can see on the right. So it's basically the reference cell contains a polyolefin-based separator with ceramic coating, so that's state of the art nowadays. And there's 2 variants from Delford for the fiber-based solution. Basically, I want to highlight 2 properties, which is the porosity. So the reference separator has 48%, while the others have 43%. But this will be clearer in the next slide. And another point is the shrinkage at elevated temperatures. At 150 degrees for 1 hour, you can see that the reference separator, even though it has a ceramic coating, which should propose higher thermal stability, is still shrinking by above 7%. So in terms of an event in the battery and elevated temperatures, this will pose a safety risk. And contrary, the fiber-based solutions show only around 1% at 150 degrees, or if you go up to a 200, 230 degrees, that's also no problem. Incotec concluded the project with the market study that basically underlines again industry trends towards sustainability, better recyclability, because if you use fiber-based separators, it's also easier for the recycling process itself. So it doesn't really lead to processes during the mechanical disintegration of cells. And also it has a lower carbon footprint and increased cell performance and safety. In the tests that we have done with our cells, it basically shows that this remark from the market study is also shown in the experimental tests. So the long-term cycling stability is shown here. So the capacity retention over time shows that if you use fiber-based separators, they have an improved life cycle stability. So it's around 3.5% after 200 cycles, and these tests are still ongoing. The reason behind is that the cellulose in the separators is capable to capture the HF that is being formed. And this HF, hydrogen fluoride, typically leads to lower capacity over time. But if you take that out, then you basically have an extended life cycle. Fast charging capabilities are also an important point when it comes to batteries for EV application, for example. In this test, in particular, the different separator types did not show any differences, but this is mainly due to the decreased porosity of the ion port separators. As I showed before, it's like 5 to 6% less than the PO type separator, and the more porous the separator is, of course, the more charge you can transfer in a given amount of time. But in this case, if you would adjust the production of the fiber-based separators, which is in the versatile paper production process very easy, and you have the same porosity levels as a PO type separator, you would have basically an improved charge capability. So faster charging and discharging. And last, due to the hydrophilic nature of the cellulose, also the electrolyte uptake is improved with fiber-based separators. So means that the electrolyte solution is absorbed and distributed very evenly and fast with fiber-based separators, and this can lead to an improved production process in the industrial cell manufacturing processes. So to summarize all this, the key benefits is safety by thermostability and low shrinkage. It is fast charging by optimized resistance and porosity. Then long cycle life by unique structure and material choice. And last, efficient production in cell manufacturing by its drying capability and electrolyte wettability. So to summarize again, it's really interesting to see that this product can propose an alternative solution to PO type separators that are commonly used now in the market, but also that this inactive component like a separator is really then actively contributing positively to the cell performance. And this was now shown in this project, and we're very happy about the results, and thank you.
Wonderful. Quick questions, or we leave maybe for the after the 6 presentations? Maybe better. I'm looking at you, Jagoba. I don't know if it's okay. Maybe let's look at the 6 and then at the end. But thank you very much and congratulations. Next is Lucas Yasunas from Ecorbio and the SEC4BAA project. Sorry if it's not pronounced like that.
Very catchy title, yeah.
Okay. Lucas is the you come from Cyprus, right?
Yes.
Yes. Lucas is the co-founder and CEO of Ecorbio. With a background in engineering and research, Lucas is driving Ecorbio's efforts to future-proof industrial chemicals by ensuring they are sustainable, scalable, and cheap. Perfect. Thank you.
Thank you so much. Thanks, everyone. I'll quickly run through what we do and the project through the INN-PRESSME testbed. Firstly, to start off, maybe a bit on what we focus on so that it kind of gives a bit of background on why this was a great opportunity for us to co-develop new solutions. Ecorbio is a clean tech startup. We're based in Cyprus, where we do our R&D, and we focus on making sure that the future chemicals that we use in industries are more sustainable. So we focus on, for example, things like upcycling waste, industrial symbiosis, making sure that the production processes that we pursue are scalable regionally, but still cheap. And the first kind of supply chain that we chose to target as a company is industrial polyurethane. So this is a widely used polymer in many sectors, including construction, automotive, but also consumer goods. As we've seen some shoe soles before, that is also one of the, let's say, application. And of course, this industry has to become greener, but typically cannot pay for the upcoming alternatives or face scalability issues where the new polymers or new chemicals are still not scalable. So to address that, we're developing a technology to produce a type of chemical, biopolyols, a key ingredient in polyurethane that can be regionally produced, scalable, of course, way cheaper than the bio-alternatives out there right now, while still price competitive with even imported polyols from Asia, and of course, not losing that kind of decarbonization potential that we can offer downstream clients. But coming back to the project, it was a big, let's say, concerted effort by a lot of developing organizations involved, a massive, I think, organizational effort to really run it efficiently for the 9 months that we had. So hats off, my hat off for CA for organizing and coordinating. But essentially, we wanted to test these low-cost biopolyols in advanced applications. In our case, it was thermoplastic polyurethane for 3D printing. Again, a big consortium of developers. So we had ITIP, CA, IBC, and VTT. I'll quickly go through how the responsibilities kind of divided. And at the end, we had 2 clients, Corbio as the, let's say, supplier of the biochemical, and the Cyprus Research and Innovation Center, who, among other things, do a lot of 3D printing for prototyping, advanced wearables, those kind of solutions. So they were looking into how to make sure that the polymers that they use in the end are more sustainable. Yeah, so in the end, we wanted to try and see how we can incorporate these biochemicals into novel formulations. In the beginning, we of course proceeded with some characterization of the polyols, characterization of the existing bio-TPU on the market. Through ITIP, CEA, we kind of tested some of those initial products and saw if they can match the technical requirements by the Cyprus Research Institute. And then, of course, even formulated some of the bio-TPU that we can then later compound with the new polymers and achieve a more sustainable alternative. The project proceeded by us providing some of those samples, both for the lab synthesis and for later on for the scaled up production of the polymer. CA led the formulation of the novel bio-TPU with the integrated and incorporated biopolyols, followed by some product characterization, printability tests, right? Seeing if we can achieve those consistent 3D filaments needed to be used and in the end use case. And once we had those promising final formulations that kind of showed that we could achieve those mechanical and thermal properties needed, we selected one formulation and proceeded with the upscaling of the production. So this was led by VTT. They had the upscaling technology enabling to produce a lot more of that polymer to be then extruded essentially into 3D printing filaments. This was the main technical challenge, scaling up, going from lab to pilot production, and this is where we had most of the, let's say, hiccups and lessons learned. The project is recently finished, so we're still having the dust settling and trying to understand how to improve this, but essentially we were not able in the end to produce a large amount of the filament because the properties of the TPU that came out from the lab and the pilot were very different, and that's why I'd say that this is the biggest challenge that we had. But coming back to us, so while we're still developing the technology, validating it at pilot scale, it was a great opportunity for us to really test downstream how these end products can be improved, how they can be incorporated with more sustainable ingredients. And without open test beds like this, a small company like ours, not having that downstream laboratory and pilot facility infrastructure, simply couldn't do. So yeah, really happy to be part of the ongoing or almost finished grand effort. And yeah, thank you so much.
Thank you so much. Okay, next will be Luisa Janussi from UAMI, presenting the wood foam project. Luisa is the Chief Operating Officer at UAMI, and she's responsible for aligning the technical advancements and the customer demands within the company and for developing pilot projects for a variety of potential applications and customers. Thank you, Luisa.
Hello, everyone. I'm here to present the wood foam project, which was a partnership to develop further the WOMI technology. So WOMI is bringing to the market a novel biofoam that is anisotropic, being very strong in one direction and soft in the other direction. We currently manufacture it in sheets, like you can see here on the first picture, and we post-process into different shapes. So we can layer it into blocks, roll it into cylinders, or imprint. We use today cellulose fibers. We have tested with a variety, but currently we are using mostly kraft pulp. And we also use other cellulose derivatives in the formula of the material, and our goal is to become a circular alternative to foam, plastic foams. The project was divided in two main parts. So the first one was to develop a roll-to-roll production for our foam instead of the sheet format that we currently have. The main goal was to speed up the production so we could potentially get an earlier market entry and achieve competitive price faster. And the other part was to test and improve the material qualities for market fit. More specifically, we were trying to get water resistance quality to the product, at the same time to ensure that it is recyclable and biodegradable. This would allow us to replace a wider range of foams in the market, both in packaging and other markets. For the INN-PRESSME services, we collaborated with 4 partners. So we used the Sutco line from VTT that was shown here earlier to try this roll-to-roll production. It was done in a way that we installed a WOMI applicator to the line and we used the roll-to-roll system in the Sutco line to reel it and make the linear movement, and also to dry the material in the line, allowing us to scale up this idea of roll-to-roll production and potentially create a new output format, since we could also sell rolls of foam and not just sheets. The next stage was to collaborate with the Plasco pilot line from VTT and with Polymaris. So the idea is to use extrusion coat of PHA to have a biodegradable plastic coating in our foam and add water and air barriers to it. In parallel to both trials, both KCL and INN+ labs were running tests to ensure that prior and after the coating process, the material was recyclable with cardboard and biodegradable. The case of INN+, due to the time limitation, we just run disintegration tests as a first step to a biodegradability certification later. The results of the Sutco line were quite interesting. We had to adapt and adjust quite fast to make it happen. Our material usually comes in parallel lines in closed sheets, but due to our material limitations and the line length, we had to develop an open pattern foam applicator so the material could be dried within the length of the Sutco line. After done, and we also had to find an open substrate so the drying could happen from both sides. After this was done, we were able to successfully produce a few 30-meter long foam rolls, as you can see in the pictures here. And this not only proves the viability of having a roll-to-roll production with our material, but also brings up a few new ideas for the market. As we have here in the picture, we have now moving from this kind of closed pattern to a potential new design that can lead to even lighter 3D structures if we use the layering with this kind of material. Then for the Plasco line, there were quite a lot of challenges, if I understood correctly, between Polymaris and VTT, as this was the first time that they were coating PHA on anything. And once that was sorted out, we ended up sending our own pilot machine foam for them to coat, since coating on such open pattern was not really viable. The Try was successful in terms that the PHA did adhere to the foam, but to calibrate the machine and make that happen, the foam got completely flattened in the process, which was not a complete surprise. And we do think that there is potential to explore this further. If we had time, we could have explored it further to try to calibrate and get still a thick foam out of the line. But we also see potential of using this thinner as a thinner layer as an outer layer for a thicker block that could be used for applications where you just need one phase with the water resistance. For the test results with KCl and IN+, we also sent the samples from our own machine for timely manners. We needed for this to start as early as possible. And with KCl, they tested with the SEPI method, our original foam, and confirmed that it is recyclable with cardboard. But with IN+, the material did not achieve acceptable degree of disintegration during the project time, which was, I think, something between 5 and 6 months. Currently, we are running other tests with IN+ outside of the project and checking what is the time range that we need to achieve this. For the second round, we end up canceling the post-coating since the amount of PHA in the foam was so much higher than the foam itself that the test would not really bring any useful results. In conclusion, we did confirm the potential to have a roll-to-roll production, and now we understand much better the parameters that we need to use to make that happen. We got a strong indication that extrusion coating is possible with the material. We just also understood a lot of the limitations behind it and the amount of work that we need to put in to make it work. We got a positive recyclability test, which for us is something very important as a small startup. And we got a strong indication that there are challenges in the process of getting biodegradability certification, and we are working on it. That's all. Thank you.
Thank you so much, Luisa. Okay, now is the turn of Ferdinand Somorowski from Fraunhofer ISC, who is presenting us the Loop BioWood project. Ferdinand is responsible for the chemical coating technology at Fraunhofer ISC and developing novel functional and also bio-based and biodegradable, I don't know how to pronounce now. Sorry, biodegradable, how do you say in English? Biodegradable, comes in Spanish to me, sorry. Coatings. The applications Ferdinand is working on range from the packaging industry to automotive applications, as well as special areas in the field of electronics, agriculture, or PFAS replacement. Thank you. Thank you, Ferdinand.
Yeah, so we stay to work with wood, but now in this project, coating on wood samples. We had some loose conversation and cooperation with Kaya Kimia before, and then the open innovation testbed gives us the possibility to work close together. And in principle, the objective is the title of the project. So we had to develop a UV curable, a wood coating. It should be bio-based, and of course some additional properties. And you see them. The focus was really on chemical stability and mechanical stability. And we had some added values like flame resistant, antimicrobial behavior. Probably you can see on the values here and also in the close cooperation with the industrial partner that it was really a project was very close to the industry and industrial application. And the approach for this project was to use our biomaterials, so silane-based and with biopolymers modified coating materials. And we plan to apply it as a top coat on wood. So the state-of-the-art layer structure is on a MDF, so on a medium density fiberboard, massive wood. Then there's always a UV curable filler and then a top coat. And at the moment it's a UV curable acrylic top coat, and we want to replace it with a partially bio-based material in our project Loop BioWood. And then we had the additional properties with hemp and flax fibers, and also a comprehensive LCA and LCI study. The project or the cooperational project was very, very close. So we worked together with INN-PRESSME and combine our hybrid materials with their bio-based fibers. We work together with Kyala also very close because they use our biomaterials to make formulations for wood. And not only on top coat, so also as a mixture with their materials. Then we took care about the application, especially also the upscaling. And then Kyla was also involved in the task of customer trials. And then, of course, covering task from IRIS, the comprehensive LCA studies. More to the practical tests and results. So we started with a selection of different formulation. We tested 9 different UV curve formulations. And what we saw is that some of them work very, very bad and only one was really promising. And so we chose them and had to improve this formulation, especially with the chemical stability, adhesion, and also the optical behavior was very important. And we used commercial additives. We used additives from our institute, also from INN-PRESSME, to integrate the new functions and new properties and optimize a lot of the contents, the combinations, also the integration methods. And what we achieved is shown here on this table. So the biomaterials at the beginning, they were very, very shiny, but we have also here some problems with adhesion, hardness, chemical stability. And with the additives, we could really achieve values that are comparable with the state-of-the-art materials, but are bio-based. We also achieved matte behavior, but it is not on this level, which can be used as a commercial product. So I think in the future we can concentrate on the glossy products, but we also want to cooperate in the future together with Kyla to develop also the matte version better. What you can see, and probably also a sample here, that is one of the customer trials. So it was really upscaled in our institute to 10 liters, and then the coating trials were done at the customer side, also characterized. And what we saw is that's very, very glossy, but quite brilliant, also a good planarization effect. It's completely stable to coffee, to water, also to paraffin, oil, household bleacher, which is very critical, and has a very, very good mechanical stability. And so from the technical aspect, I think the project was very successful, but also the LCA has a good result here. With the general assumptions Anastasia did for this calculation, we see that the global warming potential is lower than a state-of-the-art system, even when we consider the transport from our institute to Turkey. Of course, the MDF portion has the highest impact, but also when we reduce here the air transport from IC to Istanbul, we have really a reduction, a significant reduction of the global warming potential. And as a summary, so we developed a new bio-based, partially bio-based protective wood coating. It has comparable results, sometimes even better than state-of-the-art materials. We can use standard processes and also standard equipment, so it's not necessary to invent or invest in new equipments. And regarding the optics, so for the moment, focus is more on the glossy layers and not so on the matte materials. And yeah, thank you.
Thank you, Ferdinand. 2 more projects to go. So now is the turn of Thomas Hort from Cellus Circle, who is presenting us the Cellus Circle project. And Thomas is an entrepreneur with more than 25 years of experience in deep tech startup and innovation initiatives. Thomas has successfully developed and introduced new technologies, new products, new companies, and to new markets. So thank you very much, Thomas.
Does this work? My last name is not that easy to pronounce.
No.
But very good effort.
Thank you. How do you say it?
Hjort.
Hjort.
Yeah, it's Swedish. It's impossible.
Impossible.
So, how does this work? Okay. Yes. So, as many of you probably know, the textile industry today is facing tremendous challenges over the next couple of years. Over 100 million tons of textiles are produced every year. And most of it, almost all, is not recycled. It ends up on big landfills, usually far away from Europe, or it's being burned. So as a result, the textile industry represents more than 10% of the carbon dioxide emissions globally. So this, of course, is a disaster. And the consumers of Europe don't accept it. And the producers want to change it as well. And of course, EU doesn't accept it. So there are new legislations in place that will not allow burning of textiles anymore. And furthermore, all member states will, starting 2025, start to collect all discarded textiles. That's great, but there will be millions and millions of tons collected only in Europe, starting soon. And the problem is, of course, what to do with all these textiles, because there are no relevant technologies available today to take care of all the textiles if we can't burn them. There were, because we have the solution, Cell the Circle. So what we are developing is a patent filed process for chemical recycling in large scale of discarded textiles into new bio-based nanomaterial. So what we can do is that we can take or receive the bulk, the big majority of discarded textiles, any fiber, any color basically, take it through our sustainable process and deliver 3 core products. So we will filter out the synthetic fibers, usually polyester, and with that we can make new textiles out of polyester. We will also get nanocellulose. So nanocellulose is, as you know, is an established product today. What we do is that we can replace nanocellulose that's today made out of wood with discarded textile or based on discarded textile. And the third product is a nanocomposite. So that's basically a combination of nanocellulose and polyester. And with this product, we can replace compounds or pellets that's today made out of fossil products or non-bio-based, non-recycled in various application areas, for example, 3D printing or injection molding or press molding. So this is our concept. What's unique with this method compared with other technologies is that our method, what we can do here is that we can actually increase the value of the products throughout the process. So we generate value. We just not only recycle the products, we accelerate the value through the process. And this is important. Otherwise, we will end up with products that are really nice, but no one will buy them because they're too expensive. So in this project, we work together with RISE, VTT, CA, and IPC. So great thanks for a very good collaboration. More specifically, at VTT and RISE, we tested our core process. And with VTT, we developed a master batch that was sent to CA for compounding. So we made pellets out of it. And with the pellets, we could injection mold it into dog legs, as you see there. And it was also sent to IPC for the production of filament for 3D printing. And with RISE, we were able to separate in the industrial scale process the textiles into nanocellulose and synthetic fibers. Also, after the process, or after the project, we were able to use material that was developed in the project for other processes, but but this was after the project. So overall, it was a very good project. We're very satisfied with the outcome. We were able to test our processes in industrial scale pilots. It worked 100% according to plan. We were also able, we also got the opportunity to work with experts in this field. And that brought a lot for us to be able to get this interaction with experts. It was also a little bit complex because this was a chain of processes after each other, and it worked out, so we could test all the processes in our value chain. We were able to develop nice demonstrators, and for us that's valuable because when we want to attract investors or new customers, to be able to show something in real on a table is much more convincing than a PowerPoint. Even though this PowerPoint is nice, of course. But and we also got material for further testing and processing. How am I on timing? I still have time. No. How is the timing? Am I? Very good. So I would perhaps like to take the opportunity to send 2 inputs for the coming projects. One is that as a startup, we didn't have to pay, of course, for being at the pilot site, which was excellent. However, we did have a lot of costs. So I think it's important for the next INN-PRESSME projects that the pilot lines are aware of that. It's really important to do all the activities planned for, because the startup has actually quite a lot of cost in this project, even though we're not paying for being at the site. That's one thing I would like to send in. I don't want to sound negative. I'm just taking the opportunity to share some views here, because we had a really good collaboration with all the partners. The other one is that most startups have limited time and limited capital, or maybe not limited capital, but at least many different boxes to put the capital in. So that means that we had very good collaboration with the partners, and I think most had here. But in order to continue that after the project, it's really important, I think, that most pilot lines look perhaps a little bit into the business model and make sure that it's possible to continue cost-wise and from other aspects with the startups, because we do want this to continue and make all the startups into commercially viable projects. So yeah, this is more about Cellucircle. We will continue to grow the company and build own sites, design, build, and operate own sites in the scale of 10K ton textiles per year. We have also been able to attract capital from soft funding and other investors. And this is our great team. That's it.
Thank you, Thomas. I think that feedback is extremely valuable to have your startup vision. Last project is Jagoba is back on the floor, although you are presenting a BioGuard project based in UK, I believe.
Yeah, unfortunately, the guys from Versarion couldn't make it today. They will be tomorrow at the Pitch Perfect event. So they asked me to to cover the part, and I hope I will cover it properly.
Sure.
Okay, so last of the projects we are gonna see today is a BioGuard project. This is the title for the biodegradable antennas for counterfeit protection concept behind. And this project has been active collaboration between Versarion, well, one of the groups into Versarion, Cambridge Graphene Limited, our pilot plan number 5 at CDTech, and pilot line number 13 at CA. And here the idea was to develop a conductive ink for the production of these NFC antennas, typically used in applications such as anti-counterfeit. So one of the things here would be to employ graphene as a starting material to go replacing other metal inks that are currently used in the market, basically silver-based inks and similars. And this was the first objective, and the second one would be to make these things printable into paper-based substrates that could be more recyclable and biodegradable than currently employed polymer films. Okay, so we have some examples of currently used antennas based on silver inks, and most of them go printed into paper. So here the work plan was basically running in parallel as Versarian was developing the starting inks, the starting graphene components. CDTech was in charge of formulating these inks in order to enhance the capability for printing, and CA was in charge of performing this assessment of the ink printability and the final manufacturing of the antenna. So, if we come to Versarian part, they tested like different starting compounds. They went from pure graphene combined with carbon nanotubes, and they went implementing their formulation of the project until they came to these hybrid formulations in which a small percentage of silver had to be included. The point here was that we had to pay attention to the sheet resistance of the printable ink. And if we compare this to reference silver-based coatings, we had really low values, like 0.4 ohms per square for 25 microns thick printings. And here, if you go checking, the values remain still higher than in that case. And only when silver was combined in the shape of strands with graphene, we could approach such type of values. In parallel, CDTech started formulating and trying to hybridize these inks with cellulose in order to provide easily printable, let's say, ink. Paying attention, of course, to the rheology of the ink, so we prepare like different formulations. We came to two, let's say, successful ones, number 18 and 19 here, having a good rheological performance. And these formulations were easily printed, and we got really high resolution prints on paper and on different materials. But unfortunately, when coming to the measurement of the electrical properties, we failed, because at the end the use of cellulose was certainly detrimental for these kind of things. So what it was decided was, after improvement of these mixtures, so BioGuard came to this mixed silver and graphene solution with a very good dispersion of the silver nanostrands in the graphene ink. These are images from electron microscopy, and the best outcome could be achieved with a small content of silver and a graphene percentage of weight around 10%. And this would be an example of what was obtained. These antennas were printed by CA, and we finally managed to obtain this kind of good resolution prints. Unfortunately, the overall performance of these antennas was not the one targeted at the beginning of the project. But still, Versarian or Cambridge Graphene, they are really optimistic, because they saw that by these alternative preparations, they can really enter a new segment in the market, maybe not replacing silver inks for certain applications, but they could enter different market applications with lower demands than these of the NFC antennas. So at the end, it came a good alternative and a good test to open like new paths for the future for them. Probably, I mean, they will be showing about this tomorrow, and I guess they will be happy to get questions in this regard. So yeah, thank you. And this is some of the names involved in the project. I guess the guys from CA will also be coming on Wednesday for our consortium meeting. I don't know if they will be coming tomorrow, but they could also solve some of the questions. So thanks a lot.
Yes, this is better. Let's go to the next presentation, which is online, and we're going to be listening to Ricardo Capola from STAM, presenting us on the digital platform and the future business opportunities. So Ricardo is a project manager since 2018 and at STAM since 2022. He is specializing in technology transfer and the circular bio-based economy, with extensive experience collaborating with research centers and companies. He has overseen the organization of the Open Call, contributing to the definition of the operational management of the Open Innovation Testbed post-project, facilitating collaboration with future clients interested in scaling up their innovations. Ricardo, are you there?
Hello, everybody. Yes, can you hear me? I hope.
Yes, we can.
Yes. Okay. So thank you for this. I'm sorry I couldn't join you, but tomorrow I'll be at the event. So if there will be any question, I'm happy to meet you. I'll be fast since you already seen the results of part of what we have done during the project. What I would like to present to you is what will happen after the end of the project, since we have decided to keep working all together to provide services to clients interested in developing new bio-based materials. I share my screen, and you should see it now. So you already saw the results of this complex scheme in which the UITB, the INN-PRESSME project, had the opportunity to service several clients, or at least several companies, through the technologies that have been developed by our partners. The idea was to start from materials, from nano materials and biomaterials, to help companies to develop, to scale up biomaterials through new processing, through new bio-based materials, and also through testing the end products. This was possible through the involvement of several different pilot lines, for example, the foam extrusion, the dispersion coating, additive manufacturing, and other new activities that were developed by very big research centers from all around Europe. Starting from this, we have built the single entry point. So it's clear that the system is very complex, it's very difficult to find everything that is needed to scale up materials, to scale up technologies that need to enter the market. It's also difficult to manage the interaction between several different research centers that have developed high TRL technologies and that are able to provide services, not just research. So the activity that we have started and STAM, the company I'm working in, is doing is the single entry point. So a single entity that can be involved at the beginning when the potential client is interested in understanding how to collaborate with the OTB, or at least that is eager to understand how to work on their product, on their process to scale up it and reach the market. So from what we understood that could be helpful for potential clients, there is one person, one organization, the SCP, that interacts directly with the client to understand the needs of the client and the interest, the aim of the client when working on their material and their process. Starting from that, the single entry point has a deep understanding of what the partners of INN-PRESSME and the future partners of the Open Innovation Testbed have developed. So we know as a SEP what we have in our hands, and we can define the best solution for the client according to the needs of the materials that they are developing. Starting from that, we can connect with the different pilot lines and service providers, as you already have seen. So creating long chains of high-level research centers that can provide services with costly machines, so that they can provide a service that can help the client to reach the definition of new materials and new processes. This is an example. You already saw how this is organized through the open course, but starting from an issue from the client, we can provide the right partner to solve the issue or to develop, in fact, new solutions. Not only technical solution, as you can see here, BTT is IPC from Offer. They are deep technology providers. They are experts on materials. They are experts also on testing, research, and development and innovation. We also provide, however, services. For example, INN-PRESS is able to provide recyclability studies, but we were also able to provide IP protection and funding advice, and then data connection and analysis. So not only technological solutions, but also more a service solution to help reaching the market. These are a lot of information. We have developed a lot of information during the project. We have a lot of solutions, something that can be of interest for partners that are interested in working with us. Where to find this information? In the INN-PRESSME platform, in which we are gathering all these this information to make them easy to be found. Obviously, the first impact may be strong because there will be a lot to read, but you can start from our website, in which you will find everything. So, talking about the INN-PRESSME platform, here you can subscribe for free, obviously. And here you can find all the information related to our pilots and our services, other than meet with the community of companies already part of the platform, and where you can find documents and events related to INN-PRESSME. Obviously, the important part here is the reaching all the information that we have gathered from the pilot lines, with an explanation of what they can do, so that you can reach this step already with an idea of what you think may be the best solution for your technology and your development activity. Here is what you can find in our website. So even not entering too much into detail, here you can find all the information related to pilot lines that are available for our clients and that we demonstrated are working for companies in the open core. So from the process of surfaces, the biomaterials with innovative manufacturing technologies from VTT and IETIP. We have the data come from offer activities on electrodes and the new bio-based foams. Some of these you already seen in the project, in the projects from the open core that you have just seen, the synthesis of coatings, the production of polylactic acids, copolymers, nanocrystals of cellulose and nanofibrils of cellulose, and finally the bio-based inks and slurries. You already saw some success cases that were part of the open core. Now I just present to you some success stories that are part of the project. So here we have several different pilot lines and services that were involved and collaborated to build a new solution for the automotive sector. In the project, we had all the pilot lines and service providers, but also the end users. So we had the opportunity to test automotive components thanks to the help of CRF, in this case, starting from flux micro and nanofibers and from a coating developed by Fraunhofer. So all bio-based to materials to produce bio-based solutions that can be used in the market. And again, completely different sector. We had an end user that works in the shoe sector, in the shoe sole development. Again, starting from bio-based materials, bio-based coatings with innovative processing solutions, we were able to develop these bio-based solutions. I guess that tomorrow it will be possible to check the solutions because we had developed this and we have tested it during the project. And from me, this is all. I'm available for questions, and as I was saying, tomorrow I will be in Brussels with you at the event, so you can check and find me around and have a chat if you have any question. The idea now is that at the end of the project, all that you have seen done in the open core will be done in the real world. So we will provide services to companies that are interested in developing new solutions and scale up their innovations, their bio-based innovations. So I see that my time is finished. So thank you very much.
I think it's working now. Yes, thank you so much, Ricardo. And luckily, everybody will have the opportunity to talk to you tomorrow because now here we're running out of time. So thank you so much for that. And see you tomorrow. Grazie.
Thank you.
So we come to the last session of the day before the Pitch Perfect, which is open loop recycling, current challenges facing the industry and impact of the packaging and packaging waste regulation on the pulp and paper sector. And we have with us Ulrich Leverle from the CEPI, the Confederation of the European Paper Industries. Ulrich joined the Confederation in November 2005, having held several positions in the area of raw materials at CEPI. His responsibilities in his current role of raw materials director include the availability of raw material both from forestry and recycling and the policies impacting them. Thank you, Ulrich, and the floor is yours.
Yeah, thank you very much. I will give a short insight in a presentation that, but I really keep it short because I think that you are just between now here and not happy hour, but I think another event that everyone is keen on going. So I will try to be a little bit short about this, and I would like to include I give a few slides here to hint you to a study to which I was honored to participate in, that was done by UNECE and FAO on circularity concepts in the pulp and paper sector, and coincidentally this study was launched only today actually. So today was the launch event, and I think it, and then I come to a few reflections about the open loop, closed loop recycling, and also the link to packaging and packaging waste regulation. So circularity in the pulp and paper industry. So we have looked at of course the different concepts, and you know the butterfly from Ellen MacArthur Foundation and the 9 R's, etc. But for in the pulp and paper industry, it's really those 3 core principles. So one is the reducing the waste by the design, and retaining materials in circulation, and then restoring the systems from which they have been extracted. So to really have the loop also not only in the technosphere but also in the biosphere. And I think here that is how in the paper industry it has been successful to broaden the availability of the renewable raw materials to all forest-based products, and to allow for a growing economy, a bioeconomy that would substitute fossil-based materials. So we have actually reached very high recycling rates in paper. Eurostat has announced quite recently that 2022 we have 83.2% of paper packaging is recycled. In the US, 80% of mills are using recovered paper. But this recycling loop is part of a wider principle in the forest-based sector, which is the cascading use of wood, where you use byproducts of one sector in the next sector, which is not recycling, but which is the use of byproducts in an open loop. Then, of course, there's the biorefinery concept, where indeed a material that has been or used to be discarded and has been used for fuels, for example, is increasingly then used for materials and chemicals and food and feed and in cosmetics. So that is definitely one pillar. That is more linked, of course, to chemical pulp mills, but also more and more to other parts of the paper industry, including also recycling mills, so that we have really applications like adhesives and others that are also used in the construction sector again. Then I think here another one is efficient use of materials, of course, but also discovering new materials, or actually not so new materials, because those materials have been used by the paper industry long time ago and are now meeting a new interest in the sector, like agricultural residues, but also plants that are actually planted for purpose for the use of the fibers in the paper industry. Examples are straw, textile waste. I think that has been discussed earlier on, which is then fiber material that can be used in paper. So it's in this open loop. But when we come then to the core, when we come to the core circularity feature in the pulp and paper industry, I think it is really to have this closed material loop principle. So that really the design for the recycling in the products and the eco management in how to deal with the products at their end of life are really going hand in hand. And so that is, I think, a key principle, and that makes what is really the design, the feature of circularity that is most prominent, because that is also where the end consumer relates to it, because of course they have in their home, in their far away from home, separate paper bins where material is discarded and is actually not going to the waste bin, but it's going to a paper bin. So I go quickly a bit through, so that we have we don't get too much into rush, and then we can also ask questions. But so what is important is indeed that there is in paper also this existence of a market pool to facilitate that collection and circularity. And we have heard before in one of the presentations of textiles that there is this anticipation that we will have a lot of textile waste that will have to be collected, while it's not yet clear how much of use applications there will be. While in paper we have, of course, the other way around, that we have a lot of uses. We have a market in the local area, in the regional area, and even in a global area. It's a globally sought after commodity, and which creates this market pool, and where the bottleneck for actually having even more recycling is rather in the collection and sorting. And so I think one learning also for other sectors like textile and others is also that these legislative measures that really bring more collection, they have to go hand in hand with market development, so that you have actually an uptake of these materials in the industry, because otherwise you might easily end up in this imbalances between actually having a pool from industry, but there is actually no collection in place, or the other way around, you have a lot of collection because legislation is pushing for it, but the industry is not yet ready to take up this material, and so I think that needs to go hand in hand, and so in this way, I think over the last years and decades, I think these phases have been going together, and that brought us in paper to a situation where the paper and board consumption has been increasing by more than 70%, but actually the use of virgin pulp has been rather stable and increased only by 18%. So I would like to recommend you to go to this study and have a look. It's on the UNECE website. I can share the link. Maybe one last comment about the paper. About the packaging and packaging waste regulation and how open loop, closed loop is dealt there. So because indeed this week it has been finally the corrigendum of the packaging and packaging waste regulation has been adopted in European Parliament. Now in Council it will be only a formality, and we expect it to be then adopted in the coming weeks. But so there has been a strong debate about closed loop recycling, because there have been stakeholders that have been saying that packaging has to be recycled back to packaging in a closed product loop, where from a paper industry perspective, we say that it has to be still a closed loop, but a closed material loop. And for paper, it's important that paper is recycled, not necessarily back to its own application. It doesn't have to be beverage carton to beverage carton or cigarette box to cigarette box, but it has to it has to be a closed material loop where it comes to paper making, whether that is packaging or a graphic paper or another specialty paper. That is another question that has to be left also to the market, because otherwise we risk getting into these imbalances between pull and push mechanisms. So I think that is something to keep in mind also now for the secondary legislation, where design for recycling criteria are developed, but also for the new Circular Economy Act, where the Commission was also planning to review the waste framework directive and to address high quality recycling. We see that the packaging regulation has defined this high quality recycling in a way that it doesn't have to, that it's recycling back to packaging or other applications where the quality of the material is maintained. And I think with paper recycling, that we meet this requirement with our closed material loop that we have. So thanks a lot for the opportunity here, and I hope I don't talk into your happy hour.
Thank you so much, Ulrich. Almost perfectly on time. Thank you for your briefness and clarity. We still have some minutes for questions to our speakers. So including all of them, the 6 projects, and Ulrich, of course. No questions? Patrick has a question. Very good.
Regarding the fashion use case, how demanding is where is it?
Thomas, is for you. Yes.
Okay. How demanding is a big fashion industry for your application at the end? So, because if they're not interesting, I mean, it's not really relevant for the market anymore.
Yeah, no, the
it's
fashion
drastically expression.
Yeah. They do not have any requirements at all from the fashion industry. Well, they have, yeah. But I think this is it's a good question, and I think there are some other recycling technologies that started before us that focused a lot on fiber-to-fiber recycling. So taking things from the textile industry, clothes basically, and fashion, and bringing it back to fashion. That is a little bit of a challenge because the fashion industry they have really high requirements on colors and fiber and quality, and so it's a tough industry to get back to. And this has so what we have focused on been not to focus only on fiber to fiber, but to other markets. For example, our composite and compounds and pellets. So most of what we will produce will not go to textile at all. And it could go back to textile, but then perhaps in the sense of interior and furnitures or sport goods, etc. So we will be able to serve the textile industry, but we do not want to depend on them. And the textile industry will be a small part of our customer segment. But so it's a really good question. I hope the answer was
very
in line with the
question.
It
could be also a longer discussion at the end, but I don't want to waste the time.
Any other question? Okay. Don't forget to bring home this wonderful INN-PRESSME results magazine, where you can see all the 11 selected projects and the info on the project, the results, and the partners. Everything is here. So please take it and distribute it. So we're finished. Thank you very much for your attention, and we hope this was very useful. And some of us, I guess, we continue at the pitch perfect and the Bioeconomy event, which is next door, I believe. Yes, you need to be registered for that. Some of us we are. And thank you very much, and yeah, continue following INN-PRESSME project. Thank you. Bye.